Hello, 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 everybody. Today we are going to be doing quadratic transformations. This is on page 34 in your notebook. Let's get started. If you remember the last lesson, we've been working with vertex form. Because looking at this equation, we will be able to find the vertex and the axis of symmetry. But this form actually comes from a series of transformations that we're going to find out today. There is a parent function that looks like this, y equals x squared. And looking at this equation, we'll be able to find what transformations make the parent function transform into whatever the graph of this equation looks like. So we want to look at different parts of the equation, starting with a. Depending on what the a value is, we're going to know a couple things. If a is greater than 1, we'll have a vertical stretch. So even if a is negative, as long as it's a number bigger than 1, say 1,000, 18, 1.5, even negative 1,000, negative 18, negative 1.5, any of these would result in a vertical stretch, which would make the graph appear narrower or tall, like this. If a is a fraction between 0 and 1, meaning it was 3/8 or 1/2 or 2/4, it results in a vertical compression, which will make the graph look wider, like this. And even if a is greater than 1, or if it's a fraction, if it is negative, then it is going to reflect or flip upside down. So it would take the graph and look like this or this. Let's look at an example. In example 1, what is my a? If you guessed 2, then you got it. And in this case, since a is 2, that means it is bigger than 1. So it is going to vertical stretch. So the graph is going to look narrower. So just by looking at 2, I know that it is going to stretch my graph so that it looks narrower. But since it's not negative, it's going to stay facing upwards, like this. So now let's figure out h. H is going to tell us about the x-axis. So you'll notice x minus h. So that means that h is going to be affecting the x values. So it is going to change whether we're moving left, right, or staying still. Something you'll remember about h is that it takes the opposite sign. So if the equation says minus h, it's going to be moving right. So the number is going to be getting bigger because in real life, we would be adding h, and that's what makes it the negative. It takes the opposite sign. And if the form says plus h, we'll be moving left h units. Let's look at an example. In example 1, can you see what the h value is? If you guessed -1, then you got it. So since h is negative, or since it's -1, we are going to move right 1. Now let's look at k. This one we're going to take exactly as it is. We're not going to reverse it. K is going to stay exactly as it is. So if k is negative, it's going to go down k number of units. If k is positive, being added, it's going to go up k number of units. Let's look at an example. In example 1, can you see what k is? If you guessed 5, then you got it. And since k is being added, that means we are going to go up 5 units. Let's look at a few more examples, putting all that we know together to use. Please keep your notes handy so that you can reference them for the rest of these practice problems. For example 2, I want to label my A, my H, and my K. A is going to be 3. My H is going to be positive 4. And my K is going to be negative 6. That means for A, since it is bigger than 1, it is going to have a vertical stretch of 3. So it is going to get narrower. My H is positive 4. Since it's being added, that means I'm going to go right. And since it's 4, that means I'm going to go right 4 times. And my K is negative, meaning I'm going to go down. And since it's 6, that means I'm going to go down 6 units. Okay, I actually made a mistake. Since 4 is being added, that means it's going to go to the left. It's going to the left 4 units because it's being added. So that's why it's important to have your notes in front of you. I must not have been paying attention. Let's move to example 3. This one's a little bit unique. So for A, I see that my A value is negative, and that's an invisible 1. So my A value, since it's going to be 1 and negative, that means it's just going to reflect. It's not going to stretch or compress. It's just going to reflect, which means it's going to go upside down. My H value is negative 3. And since this one's negative, this one's correct, it is going to be moving right 3 times. The last one, it's not a trick. Since there's no K, it's going to be 0, meaning there's going to be no change. So I'm just going to cross that one out. And then we have example 4. My A is 1/2, and it's positive. So since it's positive, it's not going to reflect, but since it's 1/2, that means it is between 0 and 1. So we have a vertical compression of 1/2. The next thing I want you to notice is that there's no parentheses. Since there's no parentheses, that means that there is no H value. So since there's no H value, there's no change. And the last value we have is K, which is positive 7. Remember, K is the one that determines if we're going up or down. And since this one is positive, we're going up 7 units. So the key takeaway here is that if there's an A value and it's greater than 1, then it's going to get slim. If it's a fraction between 0 and 1, then it's going to get wide. And if it's negative, which could happen with either of these or with no value, then it's going to flip upside down. With the H, it's going to take the opposite sign. So if it's negative, it's going to go right H units. And if it's positive, it's going to go left H units. H is the only one that you do it in that direction. So H controls whether our graph is transforming left or right. And K is going to determine if we're going down or up. So if it's adding, we're going to go up. And if it's subtracting, we're going to go down. H only applies if there's parentheses. And if there is no K value, then that means it is 0. Go ahead and get started.